All right, video 4, lecture 4. We're going to review trig functions, the sine function, sine of theta, y over r. All right, cosine of theta, x over r. Tangent, something I often go on and get distracted from the lecture. Tan of theta is y over x. Then next comes cosecant, is the flip of sine of theta. We have secant is cosine flipped. Cotangent is tangent flipped. All right. And that pertains to the unit circle as we went over. It's called a unit circle because it has a radius of 1. Okay. And anywhere that you draw a point on here, you're looking at this triangle. The x-coordinate is this distance, the y-coordinate is this distance, and the r is, again, the radius. Reference angles. So reference angle is a fancy, very fancy way. You may have heard of these quadrants going counterclockwise. We count out 1, 2, 3, 4. As we discussed in a previous video, the coordinates here on the circle are plus plus for the xy, which makes sense because this is the y, this is the x, this is negative, this is positive, this is negative, this is positive. So we have oops, did I lose it? Where'd it go? So we have everything in quadrant 1 is positive, positive, the x and the y. Everything in quadrant 2 is, I have to do it like this. Everything in quadrant 2 is negative, positive, x, negative, y, positive. Everything in quadrant 3 is negative, 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 because we're over here and we're down here. So negative, negative, and then we have the x here is positive. The y here is negative. All right. And the idea of a reference angle is pretty simple to understand. It's honestly something that comes to mind immediately when I'm like looking at this angle. All a reference angle is really, which let's say it's 135 degrees, 3 pi over 4. The question is, what is the acute angle that is made here with this terminal side of the angle you're looking at with the horizontal, the x-axis? They just want to know what this angle is. So our answer is 45 degrees because you can see here, this angle right here, it's a straight line. That angle, which is 180, minus this angle, okay, gives us 45. And it makes sense, right? This 180 degrees, you subtract away. So subtract all this away. Subtract this away, right? So we subtract that from the 180, and we're left with this angle here, this 45-degree angle. So the reference angle of 135 degrees is 45 degrees. And that'll be useful later when you're dealing with, if you care about this angle or this rotation right here, if you care about that, well, it would be useful to know the reference angle, which is simply this angle, right? It would be useful to know that because the xy coordinates here on the circle are the same as this large, very, very large angle, greater than 360 degrees, greater than 2 pi angle. What that means is if you have this angle and we want to know the reference angle of it, I'll say the angle being considered is this one, and the reference angle, which refers to the acute angle made with the horizontal by this terminal side right here that I'm hovering over. Angle of interest, I'm calling this. At any time, you will be able to take that. So you could say your angle here is, your angle of interest is this value, blue theta equals pi plus red theta, right? Because this angle here is pi radians, this 180 degrees. this angle here that you worry about is equal to the straight angle right here, pi, the straight angle pi plus this little extra bit, this little extra acute angle, which is red theta, whatever this may be. It looks to me like it's approximately 225. So the pi is 180. Then the little acute one is 45 here. 225 minus 45 gives us that straight angle. Or you could say that 180 plus 45 equals the total, the big angle that we're looking at. It's not a highlighter. Right, I hope that helps a little bit, just visualizing it. So just know that if someone says the x-axis or the horizontal, that is an angle of 180 degrees or pi radians. The x-axis, I think, and if I'm thinking trig, I'm thinking pi. The horizontal, if I'm thinking trig, I'm thinking pi. Get 180 degrees if you want to work in degrees. It depends on the situation. Okay, so what we've done so far is look at trig functions of common angles, right? Which is what's sine of 30 degrees, what's cosine of pi, what's tangent of pi over 4, what's cosecant of, who knows, pi over 6, right? That these common quote unquote angles are this 30 degrees, which is on the unit circle, the common unit circle. Pi is over here. Pi over 4 is the same as 45 degrees. Pi over 6 is the same as 30 degrees, right? Now, the reason we talked about reference angles is because now we want to find trig functions for any angle. To do that, we have a three-step process. So step 1, determine the reference angle. All right. Step 2, identify the sign of the trig function based on the quadrant, okay? Which, as I said, is 1, 2, 3, 4, plus, plus, minus, plus, minus, minus, plus, minus. Yeah. So take an angle that's over here, trying to be a little random and come up with newish angles. To make this angle, let's say this is what, 90 plus another 60, so 150. This angle right here of 150 degrees, we know, okay, this angle is 150 degrees. So again, if we reference the horizontal, which is 180 or pi, I wish I had a green marker on here. 180 or pi, subtract our angle, means our reference angle, this is 30. And we know that in quadrant 1, right, identify the sign of the trig function based on the quadrant. And while we're in quadrant 2, so we're going to have it in our head that the x is negative, the y is positive because of this. So we just need to know what is this reference angle 30 degrees. If we were to be working in quadrant 1, what would these coordinates be? Well, they would be root 3 over 2 and 1 over 2. Okay, and then step 3, we're going to apply sine, thanks to knowing the quadrant, to ref angle. Right, so we determined quadrant 2 means minus plus. The reference angle is 30 degrees, so the coordinate here will be at 150, or sorry, the coordinate here at 150 will be these coordinates except slight difference. We are going to add the signs minus plus, and this is already positive, but we can write it for good measure. So that's a three-step program, right? So say we have this angle, which is this, and we want to know the coordinate here. I mean, you can, again, memorize the unit circle. This is just a system to help. I kind of went over this in the previous video anyway, but if this is, what's this, 270 plus another 45? If this is 315 degrees all the way around here, then our reference angle here, you can see I did the calculation just to make the angle, but it's 45 degrees. And in this situation, you can't just do pi minus your angle, because what you're going to have to end up doing is, back to my green highlighter, instead of pi, you're going to have to do this angle, that angle, minus yours, because you want this piece. So that's 360 minus your angle, which is 45. So it makes sense. And so now that we have 45 degrees, we say, okay, in the first quadrant up here, what are the coordinates at 45? It's these. And since we're in this quadrant down here in the fourth quadrant, we know that we're gonna have plus minus. So you translate this to plus minus, right? So the coordinates on the circle for this angle is √2/2, negative √2/2. So that means you can find these coordinates on the circle, the result of doing a trig function on any angle, including one where you're just going up many times around the circle, or we won't end there. You might get those. You might get a 820-degree angle. Someone might give you that. Well, let's see, what would an 820-degree angle be? First thing I would do is start subtracting 360 from there. So 820 minus 360, that's still greater than 360, so I would subtract another 360. So from that result, you can see that 820 equals 360 plus 360 plus 100. So this is a full rotation, a full rotation. So you went once, twice around, and then another 100 degrees, this is the 90. So it's slightly past that. That's the angle we'd be talking about, which we'll call it 100 degrees here. So your reference angle is going to be this angle, and that's going to be 180 minus 100, which is 80. So the reference angle is this 80-degree angle right here. Okay, quadrant 1. And then we have to apply the quadrant 2 sign, which is minus plus. And we'll have, what did I say, 80 degrees, the coordinates there. Say hypothetically we wanted to know the sine of 80 degrees. Then we would say, let's look at this sine of, what am I in? Radians, let's go to degrees. Good. Sine of 80 degrees is something around 0.98487. Okay. And so cosine of 80 degrees is, all right. And so what I found is the x and y coordinate here, right? Because this is 0.17, 0.98, and what we're looking at is quadrant 2. So instead we'll have this. So let me just write it out. So our xy coordinate there, also known as our cosine coordinate, is negative 0.173 something. Okay, it should be rounded to 4 probably, comma 0.985. That is your answer for the coordinates on the circle for x and y of this angle. Once around, twice around, and then another 100 degrees. And the answer is this, 0.174, comma 0.985. Okay. It's kind of a crazy example. Just wanted to show an extreme example. And the reason these came out as sort of goofy decimals is remember that this lecture is about finding any angle. That's why I use the calculator to find sine and cosine, is because at 80 degrees, I mean, it's not, I don't know what fraction that is. I don't know what fraction that is or what fraction that is. This one's close to 1, but I don't know what it is. So yeah, the idea is you can find these outputs of trig functions. You can find, they're also referred to as the coordinate on the circle in xy. You can find those using this reference angle system. And then these are just known quantities that at a point you're just, these are just going to pop out of your head. I've written before, 0 pi at 360, pi over 2 at 90 degrees, pi at 180 degrees, and 3 pi over 2 at 270 degrees, the coordinates here are pretty logical. They are on a unit circle, that is. Remember, the radius is 1, right? If the radius is 1, that means that's 1, that's 1. So this distance right here is also 1. So if the x and y coordinates are the distance to the left or right, and then the distance up and down or the height, well then this up here would make sense that it's 0 because you've traveled 0 paces east or west, and 1 because you've traveled the radius of this circle north to reach this point. So this point in the circle's coordinates are 0, 1. And then over here we have this distance is a radius of 1, right? We just said radius of 1, yeah. So we're going to the left in the minus direction. So we're negative over here, positive over here. We're negative going down, and we're positive going up, right? So this distance is 1, but it's in the negative direction. So this coordinate must be -1 for the x. And then the y, what is the y here? 0, there's no height. It's on the horizontal, there's no height, there's no north and south, there's a 0. And then, the pattern continues. This is 1, but it's going down south. So that means that tells me my y is -1. And the x, there's no east and west distance traveled. So that's 0 again. And then our starting point when measuring all our angles, the wonderful 0 pi, aka 2 pi, is going to be 1, 0, which should make a lot of sense by now, because just imagine you didn't introduce the circle and you just have you're in a math class that's not about circles and triangles the whole time, right? You're just hanging out, you're looking at this, you're looking at graphs, you're learning about graphs. And the professor says, okay, this is 1, 2, this is -1, -2, this is 1, 2, oops, this is -1, -2. Yeah. So when we're doing trig, we're thinking about a circle that exists right here. That's not much of a circle, I'm sorry. But this coordinate here, being 1, 0, 1, 0, is just saying, yeah, you're 1 unit to the right from your origin and 0 units up or down traveled. So all trig is all the Pythagorean things and all the circle math that you're doing is just saying, well, what if there's a circle here? If r is equal to 2, it's saying, well, what if there's a circle here? Right? This is r equal 2. This is r equal 1. That's all that's going on. All right. So I'm going to give you, let's see, maybe I'll make it right now. So here we go. The unit circle you deserve. That's not a bad circle right there. So when we're drawing a unit circle, we're just going to take care of the first things, right? First things first, the easy ones. 0 degrees, 0 pi. Our coordinate is 1, 0. This is 90 degrees, pi over 2. Our coordinate is 0, 1. And over here we'll have 180 degrees, pi. Our coordinate is -1, 0. And then we have our south pole here, 3 pi over 2, which is 270 degrees. And the coordinate is 0, -1. And then a full rotation is either 360 degrees or 2 pi, and it's the same coordinate, obviously. So then, if you have this angle on either side, or this angle, or you have this angle on either side, 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 well, then what you have is this 30-degree mark, which is pi over 6, which is root 3 over 2, 1/2. You have your 45-degree mark, which is pi over 4, root 2 over 2, root 2 over 2, 60 degrees, which is pi over 3, is 1/2 root 3 over 2. Continuing on, add 90 degrees, or sorry, 90 degrees, we'll add another 30, call this 120 degrees. And then if I look here, I have pi over 6, 2 pi over 6, which is a third of pi, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3. And that coordinate is going to be the same as this one, adjusted for the signs that belong to this quadrant, which is 2, aka negative 1/2 root 3 over 2. Add 15 degrees now because that's what we chose to do, right? 30, and then another 15 is 45, another 15 is 60, then we add 30 again. Add 15, we have 135 degrees, and that is going to be, so here we have 1/4 pi, 2/4 pi, which is pi over 2, 3/4 pi, 3 pi over 4 is another way of saying that, and that's going to have these same coordinates, but with a sign change. Add another 15 degrees, gives us 150 degrees, and I have my pi over 6, my pi over 6, my 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, same coordinates as this one, which we could call the reference angle, but with a minus sign right there in the x. All right, we keep going. That's another 30 degrees here, which is 210 degrees. Another 15 here is 225. Another 15 there is 240. And then we add 30 degrees to this angle, and that gives us 300. Add 15 to get to here, we have 315. Add another 15 to get 330. Then I ask myself, what is this in radians? Well, this is pi. Let's do it a fun way. This is pi, okay? And this is another pi over 6, right? To go from here to here is another pi over 6, so pi plus pi over 6. This is just for fun. Don't overthink it. Pi plus pi over 6, well, they need to have the same denominator. So pi is actually the same as 6 pi over 6. So this ends up being 7 pi over 6, which is what this is in radians. Beautiful. Isn't math fun to do? Okay. Then this reference angle is 45 degrees. I can tell just by looking at it. Also take these actual real angles that I drew with a grain of salt. That's the reason I'm labeling them all tediously like this. It's because these angles are not correct. And theoretically, any angle you ever draw is not going to be the exact angle that you label it as. You think about it. So what is this? The reference angle is 45 degrees. That means the reference angle is pi over 4. That means this is pi over 4 over here. This is 2 pi over 4, 3 pi over 4. Well, this has to be 5 pi over 4. Makes sense to me. This 240 degrees here this is 7 pi over 6. So I'm going to say this is 8 pi over 6, aka 4 pi over 3. 8 pi over 6, yeah. Then what comes next? So 8 pi over 6, 9 pi over 6, 10 pi over 6, which is 5 over 3. This is 45 degrees off of this angle here. And so I have a 5 pi over 4, 6 pi over 4, 7 pi over 4. I have a 10 pi over 6, aka 5 pi over 3. Then this is the 11 pi over 6 right here. Keep going, and we have a 12 pi over 6, which reduces to this 2 pi. Beautiful. And now the coordinates are easy. You guys got this, right? This is the minus plus area. This is the plus plus area. This is the minus minus area. And this is the plus minus area, which tells me that this angle here is simply, yep, root 3 over 2, 1/2, with a minus sign on both. Root 3 over 2, oops, I copied this part and I just realized. Be careful, of course, always be careful about that. A big lesson right there, if you're going to copy your reference angle coordinates and then simply add signs. Make sure you copy them correctly, because if you don't, then you're gonna end up with a mess later. Anyway, where was I? I was just copying it a second time, which is bad. So root 2 over 2 here. These are both negative. Then we have 1/2 root 3 over 2, both negative. Over here, it'll be the same as this thing right here with the appropriate signs, or this thing right here with the appropriate signs. This is plus minus, so 1/2 root 3 over 2. Same thing. Root 2, oops, root 2 over 2, root 2 over 2, except this guy gets a minus. And finally, root 3 over 2, 1/2, except this guy gets a minus. And that's your unit circle. You know what can be said? What more could you add? Maybe color. You could add color if you want. Color makes the world a better place. And we'll make the minus sign red, which is an arbitrary choice, I will admit. I'm just basing it on what I've seen before. You know, it's all we can really do. And then if we go around here, we can have a little bit of fun by putting minus and red. Minus, 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 minus. Shouldn't be any minuses up there at all. We can even put a little blue plus, 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 and plus, 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 plus. Nice. Could always say, for an example of a single one of these, which I'll do a 45 to make this part very clear. There you are. Then let's say you have to take time and really show your unit circle love. It's important. If you take the time to show your unit circle love, then I promise that trig will be a breeze and you'll get 110 in the class. That is guaranteed and honored by this channel. Dragon Mathematics. It's like cooking when they say, you know, it tastes better when you cook with love. That's how mathematics works as well. We have our final product, assuming an angle of theta here. Beautiful. And the only thing left to do is solve some problems. So number 1 here says which function is positive in quadrant 4. Okay, let's think about it. We got our 1, 2, 3, 4. So that's over here. That is x's and y's, where the x is positive and the y is negative. So which function is positive in quadrant 4? Well, sine we know is y over r, and y is negative in the fourth quadrant. So essentially we're going to have a negative over a positive radius because the hypotenuse or the radius is always positive, as we've discussed. There's no negative radius. When you're talking about geometry, when you're talking about trig, when you're talking about objects, when you're talking about distances, the actual length of one of the legs of the triangle is never negative. Though you may see like a coordinate down here is negative, the y coordinate may be negative, but the actual leg, the distance from here to here isn't negative. It's just that this coordinate is negative with respect to the horizontal. I hope that makes sense. So, logicking our way through this, sine is going to yield a minus over a plus, which is going to result in a minus. A cosine is going to be x over r, also known as a plus over a plus, which is positive. So we'll take cosine. Tangent is going to give us y over x, which is negative over positive. So no tangent. And then cosecant, as we know, is 1 over sine of theta. And as we discovered, sine of theta results in a negative. So 1 over the negative is also going to be negative. So our answer is B. Cosine is the only one. And the way to say that in words is cosine of theta is the only function that, when performed on an angle in quadrant 4, is going to result in a positive value. Right, so what I'm saying there is if you have an angle, this positive angle, theta 2, or this negative angle, theta 1, the only time you're going to get a positive out is when you do cosine on theta, either of these. So cosine of theta 1 is some positive number, cosine of theta 2, some positive number. And that is not the case for this, this, or this. Let's go to, so we want the reference angle of 240. I'm pretty confident that 225 is right there. All right, so 240 is a little bigger than that. This is our angle of interest. Our reference angle is just this piece, the angle that our terminating side right here, the terminal side, makes with the horizontal here. So this angle is reference. All right, and just by inspection, you can sort of imagine, okay, it looks like this blue here, 240. If we want this red piece, so this 240-degree angle, if we were to take out the portion of it here that makes up all of this, right, which we know how much that is, give or take. If we took that out, that green portion out of the total blue angle, which I'm gonna get rid of this so you can see, if we take all that out from our blue angle, if we take that out, we will be left with this piece. So that's our answer. Reference angle for 240 degrees is 60 degrees. And next one. Okay, let's see what we have to do to tackle this one. A point on the terminal side of an angle theta in standard position is given. Find the exact value of each of the 6 trig functions. What this is saying is there's a point on my circle here. The coordinates 5, negative 12. Okay, so off the bat, I'm just going to say that's an x and a y. I'm going to say positive negative is positive negative, right? It's down here in the 4th quadrant, as it's called. And the x is 5 units of some sort. So the x is 5 units. The y is 12 units. Trying to be more accurate with the sketches in each video. 5, and this is a length of 12, which again gives us this point down here. 5, negative 12. And we'll just make this r a boring gray line. Find the exact value of each of the 6 trig functions. Theta's right here, by the way. The first thing I'm going to do is just write out the first trig function I know, which is sine of theta. It is y over r, and I know that y is negative 12 and x is 5. I'm just going to write minus 12 over r temporarily. And then I'm going to write here 5 over r. Now you're probably thinking that the final answer isn't going to be acceptable with an r in it. So let's do a little quick Pythagorean theorem here. We look at this triangle. This is my x, so I'm going to write it here where I'm used to an x being. This is my y, and then r. So a squared plus b squared equals c squared. That's the Pythagorean theorem. We write it like this because we're working with Cartesian coordinates. And we have 5 squared plus 12 squared equals r squared. This is 25. This is 144. So r squared equals 169. All right. Then r must equal the square root of 169, which is 13. You say plus or minus, but now we're working with distances of real objects like a line in a triangle. So r is 13. Back to what we were doing after that quick little Pythagorean theorem. And we have, back to this, we have minus 12 over 13. We have 5 over 13. Tangent is y over x. That's negative 12 over 5. Cotangent, easy, 5 over negative 12. Cosecant, we flip our sign, and secant, we flip cosine. So these are all exact values. That's good. We're going to erase this page in a second. We're going to nuke it. And here we are with sine of 405 degrees. So off the bat, I'm just thinking in my head, okay, sine of 360 degrees is the sine of this point. Sine of 450 degrees, interesting. The sine of 450 degrees is going to be the same because of how we learned how to do reference angles. 450 degrees is all the way around 360 plus this, which is what, 90? So plus another 90 degrees, all the way around plus another 90. Makes sense, right? 450. So 450 degrees is all the way around plus another 90. Sine of 450 degrees, since our reference angle here now is going to be 90. Sine of 450 is the same as sine of 90, which we know is the height or the y coordinate here at this point at 90 degrees, which back to our unit circle is coordinate 0, 1. That's x, that's y, meaning y is 1. So sine of 90 degrees equals sine of pi over 2 equals sine of 450 degrees equals 1. All of those are all 1. All of that is 1. This is 1, this is 1, this is 1. Funny thing is, I was supposed to do it for 405. So let's do it actually for 405. This is 360 here. And then continuing on, the remaining angle that we end up finding is going to be 405 minus 360, rather than what I did the first time, which was 450 minus 360. Let's see, 40 brings us to 400, so 45 degrees. Same trick, right? So this whole rotation around is going to go here. This is 405 degrees. Same trick, 45 degrees. We use our reference angle, sine of 45 degrees equals, and then you choose your method of figuring that out, but you should know by now that it's root 2 over 2, root 2 over 2 for the chords, x, y. Here's what we're interested in. Root 2 over 2 is the value. Our reference angle happens to land in the same quadrant as our angle lands in the first quadrant. So since it's already plus plus, then nothing has to change. Like if we kept going and it was 45 degrees from here, then we would have to use the minus plus. But since we got lucky and landed in the first quadrant, this answer is the same as this answer. And so we're smooth sailing. If we want cosine of 420, we want 420 minus 360. So a trick I'm doing here, I guess I didn't say explicitly what I was doing, but if it's over a full rotation, you can just subtract the full rotation out, because then your terminal side, your final angle, is going to end somewhere in the second rotation. If you get lucky, it'll land here, and then you have your acute angle in the first quadrant already. And if it lands here, well, then this will be the angle that you use, but your reference angle will be this. Basically, what I'm saying is if this number right here ends up being 90 degrees or less, then that's my reference angle and my coordinates. So I'm good. Or the sign of my coordinates, I should say. So 60 plus 60 is 120. So this is 60. So that means 60 degrees right here, all the way around. This is a 420 degree angle. Same thing just happened is 60 degrees is in the first quadrant. First quadrant is plus plus. So you just use these coordinates, 1/2 and root 3 over 2. Sorry, you just use these to solve, and we know that cosine is essentially the same as x. All we have to do is cosine of 60 degrees to get our answer, and that's the x coordinate, that's 1/2. So cosine of 420 is also 1/2. This one's just like a quick quiz brain teaser type of question. If the sign is greater than 0, a lot of times in math, this is another thing that kind of tripped me up when I first started, but we say positive and negative as greater than 0 and less than 0. It's comes in handy, I guess, depending on what sentence you're forming, but it just seemed to be confusing at first. Now it just comes to me, and you'll end up the same way, right? If x is greater than 0, x is positive. Quick version of this. So sine. First thing I see in my head is y. Sine of theta means y to me. Y is sine theta, x is cosine theta, and we'll even do y over x is tangent. So when is y greater than 0? When is y positive? The y is positive up here. So our answer is going to be somewhere along this arc. And then cosine of theta is also less than 0. So I'm thinking x. X is less than 0. So where is y positive and x negative? Well, here's my x-axis here. X is negative this direction. All these x's are negative over here. So I can say that the answer to this question is over here. This is where the y's are positive and the x are negative, all along this quarter circle right here, all along this arc from here to here. Every single point will look like that. It will look like this, negative, positive. All right. So name the quadrant. The answer is 2. All right. So for 7, it's going to be the same thing. X is positive, and then tangent y over x is positive. So what quadrant does this happen in? Well, we have to think. If the cosine is positive, that means the x is positive. So that can only be things to the right of this vertical line. And if y over x is positive, that means you either have to have this happening or this happening. Both of these will result in something positive. If you have this, that's not going to be positive, it's going to be negative. And same thing if you have this, it's not going to be positive, it's going to be negative. So the place where tangent of theta is positive is in the quadrants where it's plus plus or minus minus. So the first quadrant is over here, plus plus in 1. Second quadrant is over here, it's minus plus. Third quadrant is over here, it's minus minus. And the fourth quadrant is over here, it's plus minus. So the place where tangent is positive is in here and in here. So we've solved it, right? The place where cosine is positive is the green. The place where tangent is positive or greater than 0 is the pink areas. And the place where it's true for both at the same time is quadrant 1 right here. Answer is quadrant 1. Good stuff. Here we're going to find the reference angle of 120 degrees. I know that that's about here. Quickly, again, this is 90 degrees. This is 120 degrees. That means this angle right here is 30 degrees. That means if this angle right here is 60 degrees, and that's exactly what I want. It just so happens is the angle that my angle of interest makes, the acute angle it makes with the horizontal is 60 degrees. That was a fast one, right? That's the quick and dirty way to do it. 60. The answer is 60. I hope it makes sense. So remember the next step then is, so what is the point on the circle for 60 in the positive regime here? Positive regime. Well, it's 1/2 comma root 3 over 2, where 1/2 is the x-coordinate and root 3 over 2 is the y-coordinate. And then knowing that, I apply the sine of quadrant 2, which we determined many times now is minus plus. So if I want to know what the coordinates are right here, I take the coordinates that are here and I do minus plus, right? And we usually don't write the plus. So the coordinates here are these, where minus 1/2 is x and root 3 over 2 is the y. Okay, this is in radians, a 7 pi over 4 radian angle here that I care about. This pi over 4 tells me where I need to look. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, 7, right? This is our angle, a 7 pi over 4 radians angle. The reference angle is this right here. The angle that terminating terminal side here makes with the horizontal, which is going to be 2 pi, which is a full rotation, 2 pi, the entire circle, minus everything except that reference that we're looking for the problem, right? Minus all of that. Maybe it's not very clear, but it will be if I color it in all the way, right? The answer is this right here. Our final slice, our little slice there. This pink amount, the entire circle is worth 2 pi. The angle of interest is a little bit of a Pac-Man. 7 pi over 4 leaves us this minus this, leaves us with this piece, a little pizza slice, right? Leaves us with this pizza slice of what? 2 pi. Let's see, if I want to make it have a 4 in the denominator, I'll multiply it by 4. So that's 8 pi over 4. This is 7 pi over 4. The difference here is pi over 4. So that amount of slice is pi over 4. So our reference angle is pi over 4. All right, reference angle for 15 pi over 4. How am I going to do this? 2 pi is equal to what, 8 pi over 4. That's one full rotation. We'll subtract it away, meaning we did this, one full rotation. The result of this is 7 pi over 4, which from memory is right here. But to do the systematic way of remembering, we have pi over 4, 2 pi over 4s. We have 3 pi's over 4, 4 pi's over 4, 5 pi's over 4, 6 pi's over 4, 7 pi over 4. That tells me that we go around one more time to here. This angle is 15 pi over 4. This angle here, okay, is our angle of interest. This angle here is going to be our reference angle. The difference between 7 pi over 4 and where it hits the horizontal at 2 pi is going to be 2 pi, which is equal to this, minus 7 pi over 4, meaning our reference angle is pi over 4. Alright, find the exact value of each. Same deal. An entire circle is worth 360 degrees. So 510 minus 360 leaves us with 150. Put our units on there, meaning our answer is sine of 150 degrees, which is 30 less than 180 over here, right? This is 180, this is 150. The sine of this is the y coordinate of this, which is negative 3 over 2, 1/2. The y coordinate is 1/2. So this is 1/2, this is 1/2, right? And last one, tangent of 7 pi. Well, I got a 1 pi, got a 2 pi, got a 3 pi, got a 4 pi, 5 pi, 6 pi, 7 pi. What's the tangent of this? Well, this is negative 1, 0 from our unit circle. That's x and y. Tangent is y over x. That means our answer is 0 over negative 1. Easy one is 0. Tangent of 7 pi is 0, and that's going to do it. I'll see you in the next one.